Hi viewers, welcome to YouTube channel Kangleipak Study Support. Today's topics are properties of colloidal solutions. In this section, we will discuss Brownian movement, Tyndall effect, electrophoresis or cataphoresis, coagulation or flocculation. Next is Schuldze Hardy Rule. So, without wasting any time, let's begin the class. First of all, let us discuss properties of colloidal solutions. First is Brownian movement. Colloidal particles means dispersed phase in colloidal solution, so Brownian motion. Brownian motion means zigzag motion. Okay? When we view the colloidal particles through an ultra microscope, we observe that they are continuously moving in a zigzag fashion. In 1827, Robert Brown observed such a movement of pollen grains suspended in water, and hence such a continuous zigzag movement is called Brownian movement. Thus, Brownian movement or Brownian motion may be defined as continuous zigzag movement of the colloidal particles in a sol. This figure shows the Brownian movement of a particle. In this figure, the particles are moved in a zigzag fashion. Such a zigzag movement is called Brownian movement. Cause of Brownian motion in molecules of colloidal particles. The molecules of dispersion medium are continuously striking against the colloidal particles. Okay? Colloidal particles means dispersed phase from all sides with different forces, causing them to move. However, colloidal particles being comparatively heavier move with a slower speed. Thus, Brownian motion occurs in colloidal particles. Okay, let me explain you in Manipuri also. Colloidal solution amada yauriba colloidal particles singna Brownian motion property leiribasi karigino natraga Brownian motion ulibasi karigino. Masigi maram karino sini. Masigi maram de colloidal solution amada yauribasi saruk anini part anini amana dispersion medium haiba ama aduga atopa amana dispersed phase haiba ama. Dispersed phase ibani akoina colloidal particles hairibasi. Dispersed phase singse dispersion medium da makoisi mathakta tawduna tongduna disperse tawduna lay. Aduna dispersion medium gi molecule singna dispersed phase colloidal particle oriba dispersed phase sing da side khuding magtagi different forces sing da continuously striking tawduna lay. Adubu colloidal particles sing asidi makoisi dispersion medium ga yengnaba matamda heavier oibanina yana lumba chawbanina makoisi slow speed ta move tawi. Maram asidage colloidal particles singna Brownian motion ulibani haibani. The next property of colloidal solution is Tyndall effect. Colloidal particles means the dispersed phase in colloidal solution, so Tyndall effect. Tyndall effect means scattering of light. If a strong converging beam of light is passed through a colloidal solution placed in a dark room, the part of beam get illuminated with a bluish light. This phenomenon was first observed by John Tyndall in 1869. Okay. Thus, Tyndall effect may be defined as the scattering of light by the colloidal particles present in a colloidal sol. The illuminated part of beam of light is called Tyndall cone. We observe Tyndall effect when a beam of light is projected in a cinema hall. It is due to the scattering of light by the colloidal dust particles in the air in the cinema hall. Now let me explain you in Manipuri also. Mathangda aikoina nainagadoriba colloidal particles singi natraga colloidal solution na utpa properties singdi kaino haiba matamda Tyndall effect haibasisu amani. Tyndall effect haibadi scattering of light haibani. aduna colloidal solution amada yauriba disperse phase oriba colloidal particles singna makoida strong converging beam of light ama pass tawba matamda dark room da thamba colloidal solution amada strong converging beam of light pass tawba matamda Tyndall effect utli haibani haibadi scattering of light utli haibani aduna asumna light ki beam do ingan ngalaba illuminate oirba light ki blue beam do madugi machuna bluish light oi haibani blue haipe changi haibani asigumba phenomenon se ihan hana John Tyndall hairi besina 1869 da ihan hana observe tauki amadi magi maming lawduna masigumba phenomenon asibu Tyndall effect haina khangnaki aduna Tyndall effect se aikoina karamna explain tawba define tawba yabage haiba matamda Tyndall effect haibasi colloidal particles singna colloidal solution sol amada yawba colloidal particles singna scattering of light tawbadu aikoina Tyndall effect kawi haini chamchamna hairasu yai asumna scattering of light tawbadagi illuminate tawraba light ki beam gi lambi do pato madubu aikoina Tyndall cone kawi asigumba Tyndall effect si aikoina yamna toina kadai da uge haiba matamda aikoina cinema hall da cinema yengba matamda projector dagi kapthorak liba light adu madugi light ki lambi do aikoina ingan ngana uba phangi masi cinema hall manungda yauriba nungsitu da present oiriba dust particles singduna light singdu projector dagi kapthorak liba light singdu scattering tawbadagi thoibani asigumba mangangi anganba lambi do madubuni Tyndall cone hariba aduga phenomenon sibuni mas aikoina Tyndall effect haina khangnaribasi gyan tare ko. In this section we will discuss the examples of Tyndall effect which we are observed during our daily life. Okay, the first above two pictures are the Tyndall effect shown by the colloidal particles. If a strong converging beam of light is passed through a colloidal solution placed in a dark room, the colloidal particles will show Tyndall effect means scattering of light. The beam of light get illuminated is called the Tyndall cone. Such Tyndall effect is also observed in cinema hall. Okay, in the cinema hall, the beam of light projected from a projector is get illuminated. That illuminated beam of light is called Tyndall cone and phenomenon is called the Tyndall effect. Okay, we observe Tyndall effect in nature also. If the sun rays enter into a dark room through window, the beam of light of sun rays get illuminated and we observe that illuminated beam of light. That illuminated beam of light is called Tyndall cone and the phenomenon is called the Tyndall effect. Okay, clear? The next property of colloidal solution is electrophoresis, which is also called cataphoresis. Colloidal particles in colloidal solution show electrophoresis or cataphoresis. The movement of colloidal particles under the influence of an electric field is called electrophoresis or cataphoresis. Okay. Colloidal particles carry electrical charge, either positive or negative charge. And this can be demonstrated by electrophoresis or cataphoresis process. In this process, the charged colloidal particles are attracted toward the oppositely charged electrodes on passing electric current to the electrodes. Now, let me explain you in Manipuri also. Mathangi colloidal particles singna utpa property singi marakta aikoina nainagadoribasi electrophoresis natraga cataphoresis haibasini. Aduna colloidal particles singna colloidal solution the electrophoresis natraga cataphoresis ki phenomenon natraga process si utli. Aduna electrophoresis natraga cataphoresis haibadi karino haibe matamda colloidal particles singna colloidal solution amada electric field apply tawsanba matamda electric field gi influence na maram oidana colloidal solution amada yauriba colloidal particles sing do movement tawrai masigi process asebu aikone electrophoresis natraga cataphoresis haina khangnai. Karigi colloidal particles sing na electric field apply tawba matamda movement tawra ibano haiba taragadi colloidal particles sing si either positive charge natraga negative charge oiba electrical charge sing pui aduna makhoi da electric field ama apply troppa matamda colloidal particles singduna opposite charge oiba electrode lomjuda colloidal particles move towardly bani. This figure shows the electrophoresis or cataphoresis process of colloidal particles. In this figure, we take arsenious sulfide having chemical formula As2S3 sol. Okay, colloidal solution. In arsenious sulfide colloidal solution, arsenious sulfide colloids carries negative charge. This can be shown by electrophoresis process or cataphoresis process. To show that arsenious sulfide colloidal particles carry negative charge, we take a U-shaped tube. Okay, in this U-shaped tube, arsenious sulfide colloidal solutions are added, and two electrodes are there at the two ends of this U-shaped tube. The left side electrode is connected to the positive terminal of the supplied electric source, and the right side electrode is connected to the negative terminal of the supplied electric source. As the arsenious sulfide colloidal particles carry negative charge, they will move toward the positive electrodes. Okay. Origin of electrical charge on colloidal particles. There are various theories for the origin of electrical charge on the colloidal particles. Some of them are given below. The first point is fractional electrification caused by the mutual rubbing of the colloidal particles with the molecules of the dispersion medium due to movement of the colloidal particles in the dispersion medium. Due to this reason, colloidal particles in a colloidal solution may get electrical charge. Okay. The second point is electron captured by particles from air during electrode dispersion in Brownian method. Due to this reason also, colloidal particles can carry electrical charge. Okay. The third point is an ionic colloid absorbs ion common to its own lattice during the preparation of colloidal salt. This may be the another reason. And the fourth point is dissociation of the molecular electrolyte absorbed on the surface of the particle take place producing a charge. This fourth point may also be a reason for carrying electrical charge on colloidal particles. Okay. The fourth property of colloidal particles is coagulation or flocculation. Coagulation is a process involving aggregate of colloidal particles to change into large size particles on addition of strong electrolyte. This aggregated large size colloidal particles which settle as a precipitate or float on the surface. Okay. This process is called coagulation or flocculation. For example, coagulation of negatively charged arsenious sulfide having chemical formula As2S3 sol can be done by addition of aluminum trichloride. Okay. Next is Schuldze Hardy Rule. Schuldze Hardy Rule may be stated as follows. Greater the valency of the oppositely charged ions of the electrolyte being added, faster is the coagulation. For example, for coagulation of negatively charged arsenious sulfide sol, trivalent cation, namely aluminum cation, are far more effective than divalent cations, namely barium cation, which in turn are more effective than monovalent cation, namely sodium cation. Okay.